Software architecture, as we know, is the high level design of a software system that defines its structure, components, interfaces, and relationships. We generally say that it's a blueprint or plan for the software development teams to follow when building the system, and it guides the decisions that are made throughout the development process. Without a clear and well defined architecture, most developers and architects often resort to the de facto standard traditional layered architecture pattern, also called the N-tier architecture, creating implicit layers by separating source code modules into packages. But unfortunately, what often results from this is a collection of unorganized source code modules that lack clear roles, responsibilities, and relationships to one another. This is what we often call the big ball of mud architecture anti pattern. And as architect, you must always justify your architecture decisions. So when you will be able to do that? If you know what kind of architectural pattern you are following and why you have chosen this particular one for the particular and unique requirements of your project. So let's have a look at three of the most popular and commonly used architectural patterns. The first is layered architecture, the most common architecture pattern, which is otherwise known as the N-tier architecture pattern as well. This pattern is the de facto standard for the most Java EE enterprise applications. The layered architecture pattern closely matches the traditional IT communication and organizational structures found in most companies, making it a natural choice for almost all types of business application development efforts. In this particular architectural pattern, the components are organized into horizontal layers, each layer performing a specific role within the application, like presentation logic or business logic. Although the layered architecture pattern does not specify the number and types of layers that must exist in the pattern, most layered architecture consists of four standard layers: presentation, business, persistence, and database. Now, in some cases, the business layer and the persistent layer are combined into a single business layer, particularly when the persistence logic is embedded within the business layer components. So, we can say that a smaller application may have only three layers, whereas larger and more complex business applications may contain five or more layers. And additional layers can be added to this architecture, such as service layer, which provides a set of services to the business logic layer, or a security layer, which handles authentication and authorization. The benefits of the layered architecture pattern include modularity, scalability, and maintainability. Each layer can be developed and tested independently, and changes made to one layer do not affect the other layers. This pattern also promotes separation of concerns, which makes the system easier to understand and modify. Next, we have microservices architecture pattern. The microservices architecture pattern is quickly gaining around in the industry as a viable alternative to the monolithic applications and service oriented architecture. Microservices architecture is a development approach that structures an application as a collection of small, independent services, each running in its own process and communicating with the other services through the lightweight APIs. Each service is responsible for a specific set of tasks or business capabilities and can be developed, deployed, and scaled independently of the other services. So, in a microservices architecture, the application is basically divided into small, loosely coupled services that communicate with each other using the simple, well defined APIs. And these services are designed around or organized around the specific business capabilities like user management, product catalog, order processing, etc. So, this particular structure, this particular organization of the services around the business logic and their capabilities of being independent of each other at every level offers several benefits over traditional monolithic architectures, including greater flexibility, scalability, and resilience. And it also allows for easier and more frequent updates and deployments, which can help to reduce the development cost and improve the time to market. But it can also add complexity to the development and deployment process as well. And microservices architecture requires careful design and management to ensure the services work together effectively. Next, we have the event driven architecture, another popular architectural pattern. It's a popular distributed asynchronous architecture pattern which used to produce highly scalable applications. And it is also highly adaptable as well. It can be used for small applications as well as for the large and complex ones. The event driven architecture is made up of highly decoupled single purpose event processing components that asynchronously receive and process events. It structures an application around the production, detection, and consumptions of events. And events, as we know, are the notifications or the happenings that occur when a specific activity or state change happens in the system, like user clicking a button or a new order being placed. These events are typically represented as messages that contain information about the event, including its type, timestamp, and any relevant data. In an event driven architecture, services or components within the application are designed to react to events as they occur, rather than being driven by user or system initiated requests. This means that the system can respond to events in real time and can scale more effectively, as processing resources can be allocated to handle specific events as they occur. The event-driven architecture pattern consists of the two main topologies, the mediator and the broker. The mediator topology is commonly used when you need to orchestrate multiple steps within an event through a central mediator, whereas the broker topology is used when you want to chain events together without the use of a central mediator. So, some benefits of an event driven architecture include increased scalability, responsiveness, and flexibility. It allows for more efficient use of processing resources and can improve overall system performance. Additionally, an event driven architecture can make it easier to introduce new features or functionality to the system as services can be developed and deployed independently and can be integrated with the system through the use of events. So, this is all about the three most popular architectural patterns of our time. There are several such architectural patterns that exist that are the results of the decades of maturity and design experiences in the software development domain. We have discussed the three of the most popular ones. Rest architectural patterns we will cover in the next part.